I'm Brian Ashton. This is my Lab 3 template for registers, counters, and the brainless CPU. And it started by building the 4-bit D register with an enable, um, which basically takes the four flip-flops, um, and your D, your enable, your clock, and reset. And basically, you can input a value into your D, and when your enable is on and you flip your clock, or when you activate your clock, it will read that D value and write it to your Q value as long as it is enabled, which is shown in the GTK wave that the enable was on and F was written into D. And after that clock, F was displayed in your Q value. And then when your enable is off, it's not going to display whatever your D value is at the next clock. And then the reset sets it back to 0. Um, the 4-bit up counter was very simple. Um, when it's enabled and your clock is switched to positive, then it will up your Q, and it's just a simple counter that can be reset with the reset function. Um, it was pretty simple, straightforward. I didn't really have any issues with this one. Um, this one was a little more interesting, but it still wasn't too bad to figure out how the address was. Well, we already loaded in the address into our RAM. And so address 0 was your output of 3. Address 1 had your output of 5. And using write, you could make a new address. So you could go to address 3, for example, which was empty. And you could use your data input to input 7. And then when you switched your clock to positive, that 7 would be uploaded into your RAM so that when you use that address 3, that new one, you would get the output of 7. Um, this one was also pretty straightforward, not that hard to understand. Um, and then it got to this, which was um, took a while to wire, and I had to go into some of my old circuits. And for some reason, one of the inside circuits, I think in past the RAM or the something got flipped. So I had to go into a couple of different circuits and edit them to flip them back to the right orders to make it run, which was a little bit difficult, but I was able to figure it out in a few minutes. Simulating the circuit, it took a while to figure out how all the parts played together. But again, after some practice and with some help, I was able to figure out basically how all these functions worked, how and why um, everything connected to each other. For example, with the arithmetic, adding 5 and 3 to get 8, and how the wave worked it took some getting used to, but I was able to figure out and create my own tests with the external write first. Sure, mouse is. Um, but anyway, writing C into the RAM first, um, and then reading it from your address. Let's see, let me find the wave. Yeah. So setting a new address to your new address bus and giving it the input C. And for the external write, you simply hit write with your clock, and that put C straight into your RAM for address 2. And then when you read it, that displayed C in your data bus because it was still uploaded into the RAM, even when your input is back to 0. Um, the internal, let's see, the internal write took a little bit longer to figure out. Um, by first passing it into the accumulator, writing 5, I guess using a new address bus 3, putting 5 into that address bus through the accumulator, and then transferring the accumulator to the RAM, which after all that read 5 from your address bus 3. Um, let's see, here it is. Uh, yeah, so step 1, input 5 into your input, have address 3, and then you passed it to your accumulator using the load accumulator, and then that put 5 in your accumulator with the clock. And then your data bus and ALU just output 5 as well. Then after that, write to put it into the ALU, and let's see, where is it? Yeah, accumulator to data bus, and right, there we go. So transferring or writing straight into the RAM from the accumulator, and that's how we got our 5 into our RAM, so that even when we took out that data input, again, when reading from the RAM, our address bus 3, 5 was still the value displayed all the way through. And then last was simply a couple of other random tests, and I chose to invert 3 from the address bus, which is very simple, and then doing an AND function. And to do that, first, all I needed to do was input 3, or, oh, wait. Oh no, here it is. I'm reading the wrong part. Um, it resets using your invert and pass to take our input 3 from our data put input 0, which was already in the files, and the ALU inverted it to C. Then I reset it, and to get the AND function, I had to pass 5 into the accumulator, and then I simply used our, where is it? Yeah, I used our data bus 3, or no, sorry. Our, sorry, I'm getting a little lost. I just had it. Basically, I took our original address bus 0 and the output 3, and it ANDed it with the accumulator of 5, and that gave us an ALU output of 1. Um, so very simple. And as you can see, one of the biggest issues was kind of managing all of it together, um, managing how each individual input affected the output, deciding which ones to use, how the wires all linked together. And it took a lot of trial and error to figure out. But that is my Lab 3.